Excellent.
What we've done is we've extended the cryptlv functionality that used to be available only in the Windows interpreter and the PHP interpreter, and we've added that capability to Metal, which is our cross-platform, cross-architecture implementation of Meterpreter in primarily C code. What I'm going to show here is I have set up a couple of listeners for a reverse HTTPS and a reverse TCP connection from Meterpreter, one expected to come from OS X, another expected to come from a Mips LE box. And I'm going to show both the backwards compatibility that we've made available here to where you can still use an older stageless Meterpreter and it will still connect up, as well as the new capability showing that we're actually encrypting the data as we transit it. I've got implementations here. I'm gonna run it on a Mips LE device, on OS X, and on a Linux OS. So we'll start the old stageless one. We look at our sessions. We see the session came back. We take a little bit deeper of a look at it. We can see the session came back and it says encryption is false because this is an older stageless Metal binary. If we start one of our new implementations using, I've gone ahead and turned on debugging and I'm handing it the ports directly, as opposed to this being a pre-built binary, but just a binary that I've provided after the initial build. This was not packaged by Venom, so it allows me to add a few more options. We can see some extra information came across here, and we did a little bit of negotiating on the cryptlv functionality. This time, if we look at sessions -v, if I can type correctly, we'll see the encryption is actually true here. So the actual communication is going across. It's actually being encrypted. We're encrypting the TLV payloads as we deliver them across. Another one, and this one gets a little bit noisy on the screen, but that's not so bad. If we look here, we can see this is the OS X Meterpreter coming over HTTPS with the encryption is turned on as well. So this is actually doubly encrypted. It's encrypted in the SSL layer as we do an HTTPS connection. It's also encrypted in the TLV packets that are the packet data that's being delivered. And we should be able to get one more. Because I'm using stageless Meterpreters, we can actually connect up, and the actual handler that's involved just needs to know what type of communication is going to happen. So I'm going to type this right one of these times. So we see sessions -v. We see also that off of the same handler that I'm using for the OS X HTTPS connection, I'm getting a Meterpreter Linux connection in, and we can see the encryption is turned on. We can also do, just to show that all these sessions actually work, we can run sysinfo against all of them. They should all return. It just might take a little while for the HTTP ones. Yay, they all worked. So, and that's just showing functionality of cryptlv actually working against, using Metal against multiple architectures, multiple hardwares, and allowing us to move forward. As Brent had mentioned earlier, we're looking at just one more primary Meterpreter, or that being the Python build, to get this functionality across all of our Meterpreter builds.
And we found an interesting bug in Mips, right? When we're doing embedded testing, we found a long-standing assembly bug in Mips's RSA implementation, didn't we?
Yes, we did. We've patched that in our implementation, and we're getting ready to open up the R back to the ARM embed TLS public repository. We're just trying to find a good way to give them some additional testing capabilities along with it, so that they can actually so that the fix, which was actually offered by another contributor from embed TLS, is actually can be verified and tested as they land it, so they can get a little bit better coverage in their code as well.
Cool. Thanks a lot, Jeffrey. That was awesome.
Yeah, we won't switch back to slides and then back to demos since we have so many. The next one is new command syntax from Brent.
All right, let's see. Share my screen. Awesome. All right, so what I'm showing you guys here is some stuff that I think isn't that different than how Metasploit used to work before, but I think it makes it work a lot more smoothly and makes some of the things that are kind of awkward about Metasploit a little less awkward. So have you ever been using MSF Venom to generate a payload and wondered why you couldn't use that same syntax, which basically looks like this, where you have MSF Venom, you can say different parameters like lhost equals foobar, whatever you want it to be. I mean, you just basically specify them all in the command line.
Well, yes, Brent, I have wondered that.
You wonder, like, why is it different in Metasploit framework than it is on the command line? Well, maybe there's no good reason why it was different. So in response to that, a feature that I worked on is this ability to basically use the exact same parameters for MSF Venom inside a framework. So here, watch. You saw how long that took too, right? You're like, MSF Venom takes forever to generate a payload. It takes like at least 10 to 20 seconds. So if I were to just copy this command line and paste it right here into this copy of framework I already have running, look, I've actually already generated my payload. Oh, I should use the word generate. Generate. And you can see like that, look how fast I'm generating this payload. It's so fast and amazing. So basically, if you like MSF Venom, but you really wish it was faster, you can actually do the same thing from right within Metasploit framework, and you don't have to learn any new syntax. But there's more. Have you ever been up on the command line and wondered, why can't I use the same syntax somewhere else? Like, what if I wanted to, say, run psexec against a bunch of different targets, but I didn't want to have to type set lhost every single time I wanted to do it? Well, you can do that too. So now I can type run lhost equals 192.168.56. I don't know, 102. And let's see if it works. Uh-oh, my handler failed to bind. But never mind that. But I'm like, oh, 102 didn't work. What about 103? Maybe 103 works. And look, I can actually retarget my, my exploit without having to actually do any sets. So now, basically, I can do that kind of same sort of, or maybe I want to try a different username, right? So if I wanted to do against 102 and say SMB user is, I don't know, equals administrator. You can see here, it actually will do as a user administrator. So now you can basically run Metasploit as a REPL and automatically change the parameters over and over again. Now, to be fair, technically Metasploit did have this sort of secret syntax where if you put commas between everything and added -o, it would do a similar kind of a thing. But no one knew about that. So what this has done is it made it more orthogonal and work consistently across all the different tools and environments. There you go. That's my demo.
Nice. Less set commands is always a good thing.
Yeah.
All right, next up, Teradata modules from Ted Raffle. You on, Ted?
Oh, all right, I'll cover that one after the next demo.
Okay, we will push that to the back. Luckily, we have a backup demo person. Shelby, 3-ring exploit circus. Shelby wins for the best demo title.
I did not create that. So
Oh, well.
props to whoever did.
Blame Brent. He's smiling too much.
Yeah.
It's a good one.
All right, so I have 3 modules to, I guess, demo today. So I'm going to go with my first one. It's an auxiliary module, so I'm going to go ahead. Let's do that. And so what this module does is it essentially exploits this directory traversal vulnerability in this simple web server, and it runs on XP. So set RH.
So someone wrote an assembly HTTP server that runs on Windows XP. Interesting.
So I have this running here. Okay, so the server is running, and then, okay, I got the right IP address. So then we hit run, and this will show you basically the boot information. That's the default file that it gives you, but you could choose to go for another file if you wanted to. But I'm going to go ahead and go to my next module, which is also an auxiliary module. So let's go. Okay, so this will actually exploit this video management library called SickRage. I don't actually have that open yet, so let's get this open. So basically, what you can do is you can manage different, I guess, web services here, and basically download certain videos based on what you set up. So we can go here and see that somebody actually set up their GitHub credentials, so they can download stuff from GitHub. They can go to this anime website and download videos from there. And you can also store them in like a Plex server, so their credentials stored there. So I'm going to go ahead and just show you that I can actually get these passwords, because basically the credentials are stored in they're stored and they're not hidden in the actual HTML source. So let's go ahead. Do that, and then we can hit run. And that's all of the, basically the services that are saved and the credentials that you can get from those services. And you can even get an email, username, and password that they set up there. Okay, and now for my last one is an exploit module. Let's see. So what this is it's an actual application. Oh, sorry about that. That basically you can convert a WAV file into an MP3 file. And so all we have to do is see. Payload for this. And so we can run this and we get the file that's generated. And I also have a handler that's listening on this IP address as well. Okay. Whoops, I said the wrong one. That is what IP address I needed. Okay, so I have a file that's saved here. I already have that open, so I can go ahead and just drag that to the desktop. And then I can add this here. And you can choose to, create a better title for this instead of just a general title such as that. And you can click convert, save to desktop. And so here, it actually saves a new file, an MP3 file, to the desktop. We can see here that we actually get an interpreter session open. And there you go. That's it.
Getting more than an MP3. Awesome.
That's a solid exploit.
That is a solid exploit.
Yeah, when the application continues working and
You would never know when you had the session. Good job, Shelby. Next one, Metasploit Web Service Authentication with Matthew.
A lot of demos.
Can you see my screen?
Yes, sir.
All right, so Goliath moves forward. What we are moving towards now is providing authentication on top of the REST service. We don't want anyone just to be able to access this data, especially due to the nature of the data people can gather using Metasploit. So just a quick demonstration from the REST API standpoint. I'm going to try and, we've probably demoed this in the past, so just simply requesting the hosts from the REST endpoint, except for now you're going to be prompted with an authentication error because we haven't authenticated to this particular endpoint. Now, things are sort of in the works to provide a cleaner sort of startup. We're planning to move, currently in progress, moving the MSF DB script from Omnibus into the Metasploit framework to sort of handle all of this setup and configuration. What I'm showing you now sort of has a little bit of developer tweaks in the background to get the account created, but all of that will be taken care of shortly. That would include the API token being auto-generated for you out of the box using that script. So we're going to look at it from the perspective that for whatever reason, the API token that I have has changed, or we want to change it. So I'm going to log into my user account for the Metasploit API account that I have and request a new API token. So this is the current API token I have, but I can generate as many, keep generating new ones for whatever reason. Maybe one of our tokens we suspect was compromised and we want to generate a new token for subsequent use. So with this token, I can re-request that particular endpoint using it. Right now we're providing the token via an authorization header, but it can also be provided via a query string parameter on the request to the REST endpoint, just trying to provide a little more flexibility for end users to integrate with our API. And if we do that, you can see that we are able to successfully request that resource and dump the hosts that are currently stored in the database. And the idea here is that this sort of authentication technique we're planning to use as we move forward and build future services on top of this. So third parties will be able to integrate with it rather simply using that API token.
That's awesome.
Very cool. So that basically what that means is Metasploit now has users and passwords. It has a concept of that inside a framework, and we'll be able to authenticate all kinds of services.
Exactly. And the idea is that there'll be individual tokens per user. So if you have a team using it and for whatever reason you need to terminate a user's access, you can shut down that account or regenerate a new API token and sever whatever was actually using an old token.
Cool. That's exciting. Thanks a lot, Matthew.
Absolutely.
All right. Adam is going to fill in for Ted and show us Teradata modules.
All right. And I will also use the opportunity to show off a little bit of my stuff. Because why not?
Shameless plug.
Shameless plug for all of the work I did. All right. So apparently there's this database thing called Teradata. It's a classic. Oops. So there's a database thing called Teradata. It's been around for a while, it turns out, and it was one of the first big data sort of RDBMSs if you needed that thing. So it's got lots of, it has a client, and of course it speaks ODBC because it's old enough to. And it has a client library in Python, but because we didn't want to port all of that, we decided to just use the Python client since we now have all this Python support. So we can write a login scanner for it, and then we have, once we find the correct login, we can do we've got an SQL runner module. And so you're like, well, Adam, there was a lot of work done in login scanners inside of Ruby. There's a lot of boilerplate.
Yeah.
Yeah.
How can we take advantage of that?
Well, see, the thing is, part of it at least was written in such a way that it did sit really right on top of the module. So we see that even though it's in Python, we didn't have to re-implement all of the things to get all the nice options you're used to, like setting your user pass file, or our host, our port, or setting separate username and password files, and it doing all the combinations for you. But we just have a simple user pass file. And if you get the client properly configured, which ODBC is always a little fun, you can see, hey, we can just run the login scanner. It looks like a normal login scanner. There's some extra output from the library, which is a little disconcerting. We're just that client library though, and it's better than nothing. And then type creds, and you see the cred in your database, just like normal. It's like, Well, Adam, I came across like 100 of these things, and I don't want to script Metasploit to run all of them. Well, you're in luck. Because if, let's say, you just wanted to run the module by itself just to see what it can do. I mean, Metasploit modules have never been able to do that really in the past before. But you know, there's a first time for everything. Oh, look at that. It runs.
It's like a stageless payload, but it's like a stageless module.
It's a stageless module. Now you currently do have to manipulate your Python path until we get the pip module up. But once you get it all pointed out, it works nice and clearly. Now you don't get all the cool options because you don't have all of the Metasploit code there to manage it for you, but you can set a list of user passes and you can point it to the thing. And that's really all you need in a login module, right? So we can do our host here to my very vulnerable box, and then we can do user pass. Now, of course, we don't want to like type out all the username password combinations, so you do have to do a little bit of shell scripting, which is really all that Metasploit is doing. But you just pass in these two arguments. It knows the port it normally listens on, and oh, you get all the same weird output, but you also get the same useful output. Now, it's not in your database yet, but for example, all of those log messages are on standard error. So if we do a little bit more scripting for quiet mode, you can see that if you just listen to standard out, it's much more grokkable.
Yeah, the same password on my, never mind.
But wait, what if you were like, well, that's great, Adam, but what if I have this module and it was written in something other than Python? Like, what if it was this new bespoke external module implementation that I wanted to test? I don't want to do it all in Python. I want to write it in Rust or Go or something, or maybe even a cool language like Erlang. Well, there's also Solo, and it takes the exact same command line format, and, oh, no, that one crashed.
Solo.
No.
Like in a good
Oh, yes. Yes, sorry, my Ruby environment is a little bit messed up, so I do have to specify, I do have to tell RBEND to use the actual correct Ruby that is capable of running Metasploit. And then you see that we get all the same output, mostly.
Okay, so Solo can run any external module.
It can run any external module because it uses the exact same code that Framework does.
Oh, that's awesome.
That's interesting. And so the language doesn't matter as much?
It doesn't matter at all at that point, as long as you can speak the JSON.
That's awesome. Yeah, definitely showing some new changes that are really promising. All this JSON is especially enticing.
Yeah, it's
for automation.
Yeah.
Great. I think that wraps up the demos. All really exciting stuff. Do we have any questions on the phone or in the room?
Just one on the lovely services list for Teradata. I saw it identified 1025 as Teradata. Was that anything manual, or did we add that?
Yeah. So yes, on the, here, I'll reshare my screen.
I think when we looked at it initially, it just showed us like IIS or something.
Well, 1025 is a common-ish ODBC port. And Teradata here is set by the module itself. So whenever you report a CRED, you can specify service info. And so we added a new little bit of metadata to the external module API that lets you set the service name. Also, whenever you report the CRED, the credential, you can set it manually for every credential. If you have a module that runs against multiple types of services and you don't want to set it globally, you can set it, and whenever you report the credential, and you can look in lib, MSF, core, modules, module, external, which is sort of the interaction shim between the shim module and the actual runner. And you can see whenever you create a correct password, you can add in the service name. And it defaults to the one set in the module.
Excellent.